Okay, so what happens is when you have salt, right? Okay, when it first starts, it's a crystal. The crystal, right? The crystal has a very nice color. It's like one crystal, one crystal, one crystal. The reason it has a nice color is it has the zinc ion and it has the sulfate ion. One zinc ion, one sulfate ion per ratio, okay, ratio. And then it has water molecules chemically bonded like that. When you touch it, it doesn't feel wet. Okay? When you touch it, it doesn't feel wet, but it has water molecules bonded together. Understand? Can you imagine? You touch it, it doesn't feel wet. Okay, so I'm going to show you a picture of it. Wait,
A crystal.
So if you look at this, right? Okay, when it's crystals, okay, if you touch this, does it feel dry or wet? This one or this one or this one? Dry or wet? Dry, it feels dry, but it has water molecules chemically bonded inside. You cannot feel that it's wet. But if you keep it in a container too long, the water might come out and it become like got water inside. But actually, when it's like this and you keep it out open, it's hard crystals. But there's water molecules trapped inside. If you heat it up long time, the water vapor will go out, the water will be released, and then here you get dry. Looks white color powder. Can you understand? So when it's crystals, it's called hydrated. When it's powder, it's called anhydrous. Remember? Okay? So many things can be hydrated and crystal. Okay, many different things can be hydrated and crystal. What happens is they have different amount of water molecules trapped together. So what we're going to do is we're going to take this crystal, we're going to heat it up until all the water is gone. When all the water is gone, it becomes anhydrous. Get it? Okay. So what you do is maybe you heat up, still got water. Maybe you heat up, still got water. So after you heat, you weigh, and then you heat again until you weigh until the mass of solid after heating is constant. Get it? You understand what's going on? All right. So why does a student to ensure?
All the water has evaporated.
Yeah, all water removed. Yes, that's called water crystallization. Okay, can? Do you understand? Okay. In an experiment, you need to find out. So moles of zinc sulfate remaining. So you take 0.322 divided by 161. Did you do this? Mass over molar mass? Yeah?
You get 0.00.
0.002. Okay. Calculate the water given out. So water, you take this minus this. 0.574 minus 0.322. How much you get? So you want to find the moles, you take amount of moles, divide molar mass. How much you get? Okay, so the ratio of water, zinc sulfate to water is 0.002, 0.014. So you just divide the smallest number. Ta-da! 7. Do you get that? Do you understand?
I did one thing wrong.
What do you do wrong?
The number of moles for the H2O.
What did you divide?
I calculated H2O wrong.
Okay. Okay. Okay, this one, this one, this one, I haven't teach you redox yet. I'm gonna planning to teach you redox today lah. Okay, so I'm gonna take this and we're gonna do this question. Just later we'll do this. Okay. Now we're gonna do this one. Okay, it's not all done already, yeah. Okay. Do you remember what's isotopes? So, uh, how do you find the proton? The proton, you must look at the periodic table. 16. Okay, 16, 16. And this one minus is 16, 18. Get it? Yes. Okay, same chemical property is because they have the same electron arrangement. Okay, the mass 34 grams. Because this value is 1 mole. Okay, this value is 1 mole. All right, 1 mole. Or you can just say mole. Okay, calculate. Okay, this one, how you do is you take 95 multiply 32 plus 34, 5 multiply 34 over how much? And then the question is 1 decimal point. Okay, so always read carefully. Yeah, sometimes they ask for whole number. Okay, okay, all right. Okay, so we have actually, I want to explain to you what we have done so far so that you have sort of a like a okay. Okay, you need to have an overview of what we know so that you know what's going on. Because sometimes you can just learn, and then don't know what's going on. Okay, so we have done states of matter. This one is the ionic, covalent, metallic. Stoichiometry is the equations, the moles, mass over molar mass. Electrochemistry is the anode, cathode one. Chemical energetics is the bonds. Chemical reactions is what we're doing now. So we have done equilibrium. We have done rate. And now we're going to do redox. Okay? Can? All right. So redox is two words together. It is oxidation, and RED stands for reduction. Oxidation means something gains electron, gains oxygen. Reduction means something loses oxygen. Oxidation means you lose electron. Reduction means you gain electron. And then finally, the last one is oxidation means oxidation number goes up. This one is oxidation number goes down. Okay, can you write this down? So we're going to go through one by one. Uh, just like that, it can do half a page, but it's a whole new subchapter. Lah. So we're going to do some more kilo and stuff like that.
Chemical is under chemical reaction.
Yeah, yeah. Oxidation number. Wait, really? Okay, so this is very easy. It's actually very, very easy. There's only a little bit like difficult parts. Okay, so like this, okay, don't lose the paper. We're going to use it some more, okay?
Okay.
Okay, so let's go into detail. Okay, oxidation. First one, uh, oxidation and reduction in terms of oxygen, Okay, so if I do like this, okay, who doesn't have oxygen at first? Magnesium. Magnesium suddenly becomes what, oxygen.
Yeah.
This is called oxidation. So we say magnesium is oxidized. Get it? That's what it means. That's how you explain it. So if you have an equation like this, if you have an equation like this, where it's like this, copper oxide. Okay, now, who is oxidized? Magnesium.
Stone from copper.
Yeah, stone from copper. So oxidized is magnesium. Then who is reduced?
Copper.
Copper oxide. Copper 2 oxide. So what happens is reduce or oxidize must be the reactant. Only the reactant can be reduced or oxidized, not the product. Can you understand? Okay, so in this reaction, does oxidation and reduction happen at the same time? Yes.
Yeah.
So therefore it's called redox.
Oh.
Can you write this down? Do you understand?
Yeah.
Easy, right?
Yeah.
Can? All right. So now, if I do like this, um, who is the one that caused magnesium to be oxidized? Who gave the oxygen? Copper oxide, right? So this is called oxidizing agent,
It's copper.
not copper. Copper 2 oxide. So oxidizing agent is copper 2 oxide. The definition of oxidizing agent is oxidizes
Another
another substance and then itself is reduced or oxidized.
reduce.
Yeah. And is reduce itself. Okay, so an oxidizing is agent is reduced, okay, and it oxidizes somebody else. So then who is my reducing agent?
Magnesium.
So it's the balik lah. Reduces another substance and itself is oxidized. Can you understand?
Yeah.
Okay. All right. So now we go to the second one, electrons. Okay. This one is no, very important. I want to do it later, but it's much later. Okay. Electron is like this. If you gain electron, it's reduction. Lost electron is oxidation. Remember, you must remember the this one, right? Gain oxygen, lose oxygen. Lose electron, gain electron. Must remember this
Um,
when you're doing things. You know, sometimes you do, you forget. Okay. So now, if I show you this, oxidation or reduction?
reaction.
Hmm?
Um, oh, lost electron or oxidation. It threw out two
Throw,
electrons.
so at first, the electron at the back is giveaway, ma. Can see it? So we say magnesium is oxidized.
The
Can you understand? Okay. Now if I do this, gain or lose electron?
gain.
Okay. So you gain electron because, so it's reduction. Okay. Uh,
Three, four.
can I understand? Okay, write this down, please.
Wait, for our syllabus, will we be studying radioactivity?
That one is physics.
Because I have a question for it,
What about it?
but I don't like. The particles. Okay, the nuclear number remain the same, but
No, nuclear number doesn't remain the same. It changes, what?
like for beta radiation,
Uh-huh.
the nuclear number for thorium remains the same, but one neutron becomes a proton. But then
Okay.
it throws out one electron. Why?
Are you sure you're reading it correctly?
I think so.
Because electrons are not the reason for nuclear reaction. Nuclear reaction literally sounds like what it is. Nucleus. Okay, we can see later. Okay, so can you understand? Okay, what if it's something like this? Okay, write it down first. And I want you to tell me, is this redox?
but there's no oxygen.
There's no oxygen, no electron, gone.
There's no oxygen, so how is it?
Okay, so like this. See, this chlorine is chlorine, right? Molecule, right? But this is what? Iodide, ionic or covalent? It's made from potassium ion and iodide ion because it's ionic compound. It's not a molecule. This, no, give and take. This one is potassium and chloride. And this one is a molecule. Okay, so what happens is from this to this, gain or lose electron. Okay. Yes.
The molecule is chlorine again.
Okay. Group 7. Negative is become okay, this one to here. Gain or lose electron. Yeah. Iodide.
It used the electron.
Yes. So this is oxidation and this is reduction.
How is it oxidation without oxygen?
Just not you. Here. Gain electron and lose electron. Okay. So this, what you say is chlorine is reduce, gains electron. Iodide, not iodine, iodide ion oxidize. You done? Done? All right. Okay, I'm going to give you a few examples. So only based on electron transfer Only based on electron transfer, you say whether it's oxidation, reduction, or redox. Okay, can you understand?
Yeah.
Okay, only one of this is not redox. The rest is either oxidation or reduction or redox. Only one of it is nothing.
Huh?
That means only one of it is not redox.
Not redox is the first one.
No,
The first.
everything is something. That means it's either oxidation or reduction or redox.
Oh,
Only one is not redox at all. Not oxidation or reduction or redox.
okay.
Get it?
Yeah. What,
Okay? Oh, you're doing
I'm doing first and I'm casual.
Okay, good, good.
Yeah.
Nana? Okay. So this one is what? Oxidation reduction?
Reduction.
Reduction.
In.
Because it gains electron. Okay, this one? Is it redox?
Yes.
Yes, because this one is sodium ion, chloride ion. This one is sodium and chlorine.
Chlorine is.
No.
No.
Because okay, this one you start out with chloride, right? So this one, yeah. Not this thing, but this equation, you start out with chloride. You start with chloride. Chloride becomes chlorine. This is oxidation. You start out with sodium ion, right? It becomes sodium. That's it. So yes, it is redox.
What?
This to here is reduction. This to this is oxidation.
Okay.
Do you get it now?
Wait, let me go.
Okay. You think a bit, This is basically a electrolysis reaction. Okay. Y'all take few seconds to absorb this knowledge. You get it? Get it? Okay, is this redox? Yeah.
Yeah.
Why?
Because energy.
Oh, yes. Okay, good, correct. This one oxidize to Mg2 plus. This one is oxidation.
And then Cl reduce.
Cl2 reduction
To reduce.
to Cl negative, correct. This one is reduction. Okay, can?
Yeah.
Okay, this one is
Nothing.
not redox. Get it? Get it?
Not really.
Not
Not
redox.
really on ox. You know.
Yeah, correct. Make sense? Make sense? Okay, now we go to something called oxidation number.
Reduce the oxidation.
Wait, no, you're not there yet. Wait. Okay. What is oxidation number? Oxidation number is a number given to show how many electrons are received, gained, or shared. How many? Okay. So calculating so oxidation number is also known as oxidation state. Okay, so there are a few laws that we follow. Okay, first law, oxidation. Wait, I write down first. State of all elements equal to zero.
What?
Wait, oxidation state of ions equal to the charge, the total sum of oxidation state is OS, or ON, of a compound equals to zero. Okay, and then oxidation state of oxygen in a compound equals to -2. Oxidation, state of hydrogen in a compound is +1. And okay, wait. The last one is group 1 is +1 in a compound. Group 2, +2. Group 3, +3. Transition metal, various oxidation states. Okay. Write this down. I'll explain to you one by one.
Wait, if it's group 5, then is it negative?
Not necessarily.
Negative.
Not necessarily. I'll explain to you. I'll explain to you in a bit.
Yeah.
Okay. So let's look at this. Now, sodium. When I write sodium like this, is it an element?
Yeah.
So the oxidation number is 0. Okay. When I write chlorine like this, is it an element? Yeah. So the oxidation number is 0. Okay. If I write S8 like that, is it still element? Yeah. Oxidation number is 0. Okay. Now, in a compound, this is in compounds, meaning if I have magnesium oxide, magnesium is group 2. So because magnesium is group 2, the oxidation number is +2. And I just told you that oxidation number of oxygen is usually -2. Usually negative. There's one exception. I'll show you later. Okay, so this is -2. So the sum is 0, meaning that if I take +2 plus -2, does it equal to 0? Yeah. Ta-da! See? So easy. That's it. Okay. So like this, if I have aluminium oxide, okay, aluminium is in group 3. So +3. How many do I have? 6. Because times 2.
Yeah.
Get it? Plus oxygen is -2 times 3. Total equal to 0. So in a compound, the total equals to 0. Can you understand? Okay, so if I have something like this, K2SO4, I already know potassium is group 1, positive 1, times 2. But I don't know what is sulfur. I don't know. Sulfur is not in our list. So sulfur is X. But I do know that oxygen in a compound is usually negative 2 times 4. But the total must equal to 0. So what is my oxidation number of sulfur? Positive 6. So oxidation number must always be positive or negative. Okay, can? Make sense? Okay, now, are you okay?
Yes.
Okay. If I have FeCl2, but this one is not group 1, group 2, group 3. So I know that Cl is chloride ion. So therefore, this must be Fe2 plus. Correct or not? Correct? So the oxidation number of this must be positive 2 because oxidation state of ions is similar to the charge. Get it? Can understand? Okay, why don't you write these examples and I'll give you more examples. Okay.
This oxidation.
Okay, so which comes back to this question. This is the one in your paper, right? What's the oxidation number of sulfur?
0.
0. And sulfur in SO3?
Wait. Group 6. Group 6.
No, not like that. I literally just taught you. Positive 6.
What?
Because I just taught you oxygen in compound negative.
Oh my god.
Literally. Literally, I literally just taught you.
Bias.
Okay, can I understand?
Yeah.
Okay.
My god.
Okay, you know what? Okay. Just now we had some more questions right here. Okay, your brain fried already. Why don't you do these questions instead? Okay, okay.
Okay.
That's worse out. Okay, then I give you easy. I give you easy stuff. I give you easy stuff.